Hello, welcome to Math 1115 Alternative Delivery for March 16th, 2020. Active learning is required here. We're covering Chapter 4.3 in this lecture, so make sure you make liberal notes of this. We're going to look back and we're going to do a couple of problems just to get situated. We're going to talk about number 37. If the tangent of theta is equal to 3 over 4, what is the value of the sine squared theta plus the cosine squared of theta? And here it's important for students to realize this notation. Sine squared theta means you take the sine of theta first and then you square it. And we're also going to do another problem. If the sine of theta is equal to 2 over 3, what is the value of the secant squared theta minus the tan squared theta? Again, secant squared theta is found by finding the secant of theta and then squaring that. So, if the tangent of theta is equal to 3 over 4, that means we have a right triangle where the opposite divided by the adjacent angles to theta is 3 over 4, and that means we know 2 of the 3 sides, so we can use the Pythagorean Theorem to solve for the remaining side. So the remaining side is 5, and that means the sine is going to be 3 over 5. The cosine is going to be 4 over 5, and if we square each one of those, we will get 9 over 25 plus 16 over 25, which is going to be 1. That is a trigonometric identity. That's really going to be true for any angle theta. Similarly, in problem 38, if the sine of theta is equal to 2 over 3, then we know that the opposite over the hypotenuse is 2 over 3. We can use the Pythagorean theorem to find the remaining side, which is going to be the square root of 5. So the secant is 3 over the square root of 5. The tangent is 2 over the square root of 5. I square each of those in turn. I get 9 over 5 minus 4 over 5 is 5 over 5 is equal to 1. I'm going to remind you here of something I mentioned in passing the other day, but there are 2 fundamental special triangles that I am going to expect you to commit to memory, and that means I may someday ask you a question without a calculator dealing with these. A 45, 45, 90 right triangle is an isosceles right triangle. So the length of this side and the length of this side have to be the same, and the sides by the Pythagorean theorem are going to be in a ratio of 1, 1, and the square root of 2. If I have a 30, 60, 90 right triangle, what will happen is that the sides are going to be in a ratio of 1, 2, and the square root of 3. That means that the side opposite the 30-degree angle is always going to be 1/2 of the hypotenuse, and the remaining leg is going to be the square root of 3 times the shortest side. And so you should be prepared to give me exact values without using a calculator, not only for these 3 trig functions, but for all of the trig functions that we spoke about. Here's a note, and this has to do with the way they round off in the back of the book. So these are the rules about significant digits. I'm not going to hold you especially accountable for this, but I am going to expect you to understand that is how the rounding off is happening in the back of the book. As we previously said and did, we talked about, given a theta, find the sine, the cosine, and the tangent of theta using your calculator. So given an angle, you can find those 3 trig functions. We also talked about how you can have those trig functions and use the inverse sign to go back and find out what theta is. These work not only for those, but for all trig functions, and that's the extension of this effort that we're going to do right now. So let's look at problem 14. Problem 14 asks us to find the value of the trigonometric function cosecant of 22.81 degrees. You don't have this in your calculator, so you have to realize that the cosecant of an angle is 1 over the sine of that angle. And so we're going to use that to do this calculation. So to find the cosecant of this angle, we have to say it is 1 over the sine of that angle. Your calculator must be set in degrees, and we get this answer, and we round it off according to what they said in table 4.1. Here's another example. I guess I said 32, but this is going the other way because we now know that the cosecant of theta is 1.002. But you see, we don't know, we don't have a calculator button that tells us about the inverse secants. So we have to realize again that this is 1 over the sine. So the sine of this angle theta is 1 over 1.002. And so that's what we do. And then we take the inverse sine of this number, 1 over 1.002, and we find out that the answer is 86.38 degrees. And again, you can see that we round the answer off according to those rules that were in table 4.1. Here again, the suggestion is that you're using the calculator to verify these relationships are true. Previously, I showed you that the sine squared of an angle plus the cosine squared of the same angle is always equal to 1. That's an example of what we call a trig identity. And here we're just verifying that that is also true for this. But this is good practice with your calculator for you to give that a go. And notice that the way you type this in is different than the way it is written. So make sure perhaps you practice that. Here we're doing problem 54. That means you want to find the cosecant of theta, but I tell you that the cosine of theta is equal to this number. Well, now what we're going to have to do is we're going to have to realize that the cosecant is 1 over the sine. So we're going to have to figure out what is the sine of this angle. And so what we're going to do is we're say, well, what is the angle? And so if the cosine of theta is equal to this, I know that theta is the inverse cosine of that number. So punch that into your calculator and ensure you get this. And then I'm going to take the sine of that answer. And again, you can put it in your calculator this way, the sine of the inverse cosine of this number. And what will happen is you'll find out what is the sine. But notice that the cosecant is 1 over the sine. And so it is relatively involved, but you will find out that the cosecant of theta then is 1.006. This is well worth practicing a bit. There are word problems because life is a word problem. And one of the word problems that you have deals with Snell's law, which talks about how sound waves are bent. And you can see that, and you perhaps observe this, that if you're looking at a fish in water, the fish isn't often where you really think it is as you're looking at it. So this is called Snell's law, and it does involve trigonometry, and that's what problem 55 is about. So according to Snell's law, if a ray of light passes from air into water with an angle, then the angle of refraction, theta sub r, is given by this equation. And so they ask us to find theta sub r. So look, you have sine of 45 degrees is 1.33 times the sine of theta r. So we're going to solve for sine of theta r and then use the inverse trig function. Let's look at the work. So we know this from the problem. This is given. So the sine of theta r, I divide both sides by the coefficient 1.33. And I plug this into my calculator and this into my calculator, and I get this number. Now that means that the sine of theta r is equal to this number, and so I will take the inverse sine of both sides. I will say theta r is this, and using the round-off scheme from table 4.1, I get that that's 32.12 degrees. There's another problem that we're going to look at, and that is problem 60. A submarine dives such that the horizontal distance it moves, that's up here, here's the picture, the horizontal distance it moves and the vertical distance as it dives are related by theta is equal to, the tangent of theta is equal to v over h, or v is equal to h times the tangent of theta. And here theta is the angle of the dive, you can see it in the picture. If theta, they ask us to find theta if h is 2.35 and v is equal to 1.52. So we're going to use these equations that we have to solve that. And so we'll say v is equal to h tan theta. These are the numbers that were given. in the problem. So tan theta is the ratio of those two. Plug that into your calculator, and you take the inverse tangent of that, and you get that this is 32.9 degrees. That concludes this section. Make sure you read it. Make sure you do the problems that John has assigned, and I will have office hours available for you to call in if you have questions as well. Take care.